See, the first problem says determine the horizontal velocity at which the girl must throw the ball. See, this girl is throwing the ball with horizontal velocity u, so that it bounces once on the smooth surface and then lands in the cup. So she leaves with horizontal velocity u, this ball. It goes, bounces here and again comes back and it exactly falls in this cup. Take E as 0.6, neglect size of the cup. And so with this data, the cup is 8 meter away and the girl is throwing it from 3 meter height from the ground. With this data, what we want to know is what should be the value of u so that it exactly falls in this cup. Okay. Now, if u is the horizontal velocity and if we accept that these both are projectile motions, then from the basic fundamental of projectile, that horizontal velocity of the projectile never changes. We can safely write 8 is equal to ut1 plus ut2, where t1 is the time of travel of first projectile and t2 is time of travel of second projectile. So if we can work out t1 and t2, I think we'll be able to get u. So let's work on t1, which refers to the first part, that is first, you can say, projectile motion of this ball, which starts from 3 meter and hits the ground. Okay. Now if I use for this height s is equal to ut plus half at square equation, vertical direction velocity being 0, this u is 0, and instead of a there is g and instead of t there is t1, and I can evaluate t1. So this work is done. t1 is evaluated. Now I have to make efforts to work out t2. Now before that, let's work out with what vertical velocity this ball hits the ground. That will be v1 is equal to gt1. We use v is equal to u plus at in vertical direction. U is 0, A is G, and therefore, and T1 we already worked out. So it is GT1, 7.67. And now see this, if you see 7.67, it hits the ground and then it bounces back. So using collision with infinite body knowledge, this works out to 4.6 because 7.67 into E, you see 0.6 will give 4.6. Now as far as horizontal component of velocity is concerned, U remains same, and even after collision U remains same. The reason is that line of impact is vertical. So in horizontal direction there is no change of velocity before or after the impact. So with this, what we have managed is enough data to start off with the second projectile motion. Now, if you work out time, this total time of flight, that will be twice the time it takes to go up. And time it takes to go up will be velocity 4.6 divided by g. You know, it follows again from our basic equations, our basic equations. So T2 is 4.6 by g, and total time of flight will be twice of this, so it will be 0.94 seconds. Now that we have T1 and T2 both in place, we substitute them in this equation. So you get 8u these two times, and you can work out u as 4.65 meters per second. Okay, let's look at one more problem. It says a ball is thrown downwards with a velocity of 12 meter per second at an angle of 30 degree with horizontal from the top of the building 12 meter high. See, this 12 meter high, this is thrown, this is 30 degree. Find where the ball will hit the ground second time if coefficient of restitution between the ball and the ground is 0.75. So it comes here, again bounces back. So again it is projectile, direct impact with infinite body, and again it is projectile. All right. Total distance, if this time is t1 and this time is t2, that is going to be ut1 plus ut2. Now let's work on individual projectiles. For this projectile, using s equal to ut plus half at square, we can work out T1 very easily. And we can also work out V1, the vertical velocity. The vertical velocity at the end of this projectile motion. That will be V using V is equal to U plus AT. And then vertical velocity, then you see the U is here given 12 cos 30, so that is 10.4, and there x1 therefore is horizontal velocity 10.4 into the time 1.07, so that is 11.13 meter. Now when we talk of V2, it will be, see, it will be like 16.5 it is hitting, so it will go up by 16.5 into 0.75, the E 12.375. And horizontal velocity of projectile was 10.4 here, it will be 10.4 here, and after the impact also it will be 10.4, because here again impact is in vertical direction. So here you get your V2. Now you are enough information to work out T2 now. Number of ways of doing it. We have chosen this. Like see, we find this T2 by that is height required to reach the time required to reach the maximum height by V is equal to U plus AT. And then from this T2, twice of that will be the total time of flight. You get capital T2. And then x2 will be 2.52 into 10.4, that is 26.2, and then you can use here, you can use this. Only one small point is here. This T2 what we are referring is actually the capital T2, 2.52. So final x is 11.13 plus that is x1 here, and x2 is 26.2, and that is 37.3 meters. So what we have done here is we have combined knowledge of projectile and knowledge of impact with or collision with infinite body, and got the required answer, and this comes to 37.3 meter. Only there is small error in this presentation, and that is, see, this capital T2 is 2T2. So what should have been here x2 is U capital T2. That's the only thing. But I'm sure this step makes it clear. Thank you.